It's polynomial classification time. Hey, everybody out there. It's Mrs. C, and I'm coming to you with another video on classifying polys. I know I have done another video, but it was a while ago, so I'm coming back with maybe a better looking video, I hope, and just a little bit more clarity on classifying polynomials. So what's the deal with classifying polynomials? Well, maybe we should start with what's a polynomial. I think that that's a good place to start, don't you? Well, polynomial, coming from the Latin derivative poly meaning many and nomial meaning nomial, so many nomials is pretty much how I look at it. What you have is you have an expression usually given to you. Oh, hang on a minute. You have an expression that's given to you, and you need to oftentimes simplify it down so that you know what kind of an expression you're looking at. So let me just throw down some examples of polynomials. I think if I throw you down some examples, you'll be able to understand what a polynomial is. It's a many-termed expression is my best bet. So mono means one, right? Bi, two, tri, three, and poly again we said means many. So when we're classifying a polynomial by its terms, we're saying that a monomial has only one term. And what makes a term? Well, what makes a term are pluses and minuses between numbers and letters, pretty much. So if you put a plus or a minus between something, then you pretty much give yourself two terms. The question is, once it's simplified, do you have two terms? So let me just throw down an example here. I'm going to erase, but I'm going to have to be crafty. So I'm going to erase it by using black. Okay. If I gave you 3x, can you do anything else to it? Can you combine it? Can you simplify it? Anything? Anyone? Bueller? Anyone? No. 3x is as good as it gets. How many terms? If I create a term by separating it with a plus or minus, if there is only one term, in this case right here, this would be two terms, see? 3x plus 1, there's two terms that can't be combined. Can you combine a 3x and a 1? No, you can't. They're not like terms. So in the case of good old 3x, it is one term. And so it is considered a monomial if you are classifying it by its terms. 3x is a monomial. Now, if I said 3x plus 1, now I have two terms. I can't combine 3x and 1, and now I have 2, and bi means 2. So a binomial, 3x plus 1. Now, how can I keep with this fun little 3x and the 1 and just keep making it, changing it up? Well, how would I add something to this that would make it 3 terms? Now you might be saying, well, just add another number, like plus 6. Ooh, thinking. Would that be a trinomial because it's got 3 terms? What's holding me up? Well, you got it. What's holding me up, as I said, can't be simplified, and I'm pretty sure 1 plus 6 is 7. And if 1 plus 6 can be simplified to 7, then 3x plus 1 plus 6 is the same as 3x plus 7, which, ooh, that would also be a binomial. So, oh, look, I never put the 1 down here. 3x plus 1, 3x plus 7, those are binomials. So we're back to the same quandary, aren't we? What can I do to 3x plus 1 to make it a trinomial? Can I add a 5x? No, because 3x and 5x would combine to give you what? 8x. Then you'd have 8x plus 1. You still have a binomial. Another nice example of a binomial. Oh my gosh. So if I go back to the original, I think I had a 3x Then I added something to make it a binomial. I added a 1. And now I'm trying to figure out what can I add to this to make it a trinomial. And every stinking term I come up with can be combined with a term that's there. So, pick a term to add to it, that kind of a term that is not like the other terms. So what kind of a term do I have? I have a constant. I have an x term. Can you think of no other term that would not be a constant or an x term? Absolutely. You could say y. Just throw down a different letter, right? Well, now, those are 3 things that can't be combined. Absolutely. Can you throw down an x term instead of a y term? You can, but what would you have to do to the x? Well, since we've been in exponents, I'm really glad you said it, you could just throw down an x, but with a variable, with an exponent. And this would be the most common thing that we will be dealing with in future, so I would actually like to use this example. So we have a 3x, we have a 1, and we have an x squared, and we know we cannot add or subtract those together because they're not like terms. You can't combine an x term with an x squared term. And so there is a very nice example of a trinomial that is in terms of x. There's only x's. There's no y values. Now, I always, it can't really alphabetize to put this in order, but what I do is I put it in what's called descending order by degree. And that's just a fancy way of saying put the highest exponent first and rearrange them like so. So you put your x squared in front, followed with your x, and then your constant in the back. Well, what can we do to this, guys? Now we're stuck with, I'm going to move this out of the way. Just going to cleaning up a little bit here. What can I do to make it a poly? Now, a poly meaning, the reason I put, these are all polys. The reason I put the poly down was, what do you call it if it exceeds 3 terms? For example, what if it has 4 terms, or 5 terms, or 6 terms, and none of them can be combined? Well, then we refer to it as a polynomial. We don't refer to it more specifically as a monomial, or binomial, or trinomial. So can you come up with something else to add that would make it 4-term polynomial? And that's what we say. We'll call it, in this case, we'll call it a 4-term, if you're using red, 4-term. Didn't quite get the whole lettering there. Okay, what can you do? Oh, I heard it out there. You can add another exponent that's an x, but that isn't an x or an x squared, right? So let's have a little bit of fun and just say minus, because we've used only pluses, and let's put maybe a number in front of it, like 2, and we'll say x cubed. Now we have to write that, and I don't even know if I have room over here in my polynomial, so let me just cut off the nomial, and we'll just keep it poly. So I would put the highest one first, which is the negative 2x cubed. Bring the sign with the term. And then we're going to follow it with a positive x squared. And then a plus 3x and a plus 1. That's an example of a 4-term polynomial because it has 4 terms that can't be combined. Right? Easy breezy, right? Well, maybe not. It's a lot of stuff to get, but that's it. That's it. So how do you identify if it's a monomial? If it has 1 term after it's been simplified. Binomial, 2 terms after it's been simplified. Trinomial, 3 terms after simplified. And 4-term, 5-term, 6-term, 7-term, we refer to them as polynomials just by term. Next. Polynomial classification by degree. Okay. Well, remember triangles, you can classify them by their sides, but you can also classify them by their angles. For example, you could have an equilateral triangle. That means that it has all of its sides are equal, right? But then you could go further and classify a triangle by the actual measure of its degrees. For example, an equilateral triangle just happens to always, sorry, geometry is not my thing. An equilateral triangle also has the same size measure angles, which would have to be 60 degrees. And if you're under 60, if you're under 90, you're considered to be an acute. So you can also classify a triangle as being an acute triangle. So you could say it's a equilateral, or you could say it's acute. Well, the same thing is going to apply now, because you can call, hang on a second, sorry, I should be using the eraser. I get confused on what tool to use to erase things. Okay. You can classify polynomials by their terms, we just did, but you can also classify them by their degree. So you're wondering probably what the heck is a degree? Well, you might have heard me say it already. A degree is the numerical value of the exponent. So for example, 4x to the fifth is a fifth degree. We could have another example. Oh gosh, see, it does get a little confusing with the eraser tool. We could do another one, say x cubed. That is a third degree. And so we have first, second, third, fourth, and nth degree. There's more. I probably should have written, I think, a fifth, so I'll probably write the 5 down there. So let's get started. Constant. If you're classifying a polynomial by terms, or by degree, you would classify any number by itself. For example, the number 3, the number 5, the number 1/2. You would classify them as constants. That's pretty straightforward. First degree. If you have a variable x and it does not show any exponent, its exponent is implied to be a 1. And so an example of a first degree polynomial would be x. Or if that's too easy, you could say 3x. You could also say 1/2 x. Second degree would be if its exponent was a 2. And so on and so on. So let me, I think that's pretty straightforward, and I've got a small space, so let's just do it this way. I'm going to give you 3x to the 4th minus x squared. So my question to you is, what degree classification would you give this polynomial? Well, you look to see what its biggest exponent is, and in this case it's a 4, right? And that is how you classify it. It's a 4th degree polynomial. I know you might be thinking, I don't get it, because it's actually so easy, it can be a little confusing. So let me just show you, it's really not that confusing. Let me give you one that's out of order. You know I love to put them in order. This time I'm not. What about that? 2 plus x cubed minus 7x squared. What is the degree classification of this polynomial? Find the biggest exponent, and that's the degree. It's a 3rd degree polynomial. Now, I was trying to confuse you because I gave you a big coefficient. I gave you 7. The coefficient has nothing to do with classifying a polynomial by its degrees. Only the exponent is what you're looking at, and you know that 3 is bigger than 2, and therefore that would be the degree classification. I know you're thinking there has got to be a trick because this is way too easy. In fact, look at the nth. What the heck are you supposed to do with that? Well, I'll show you. Let me say 4x to the 12th minus 2 x to the 17th. Okay, so by degree, which is the highest exponent? Biggest exponent is the 17. Would you agree? Of course you would. And so you're looking and you're saying, well, I see first degree, second degree, third degree, fourth degree. You didn't list 17th degree, Mrs. Caruso. I know I didn't. Implied in the use of the terminology nth. Nth refers to whatever you put th. Okay? So that's what nth degree means. It means fill in the n with the number and put a th at the end, and you've got your degree classification. So in this case, 4x to the 12th minus 2x to the 17th is a 17th degree polynomial. That's what the nth means. So sorry, you thought it was going to get harder. It didn't. It's just a way of me not having to write an infinite number of terminologies. Okay, you were wondering if it got any harder? Just a scotch. Okay. Classifying by degree, that's the last page. This is the easy way, first, second, third, fourth. This is the more, let's say sophisticated way, because for the words, for the first, second, third, fourth, there are words, vocabulary that go with it. So let me just break it down. The good news is you don't have to go forever. You just have a specific number of degrees that are so special they get their own words. Okay, so let's break it down. Constant is any number by itself, and you already know that because that was on the last page. So if I give you the number 5, or the number 19, or the number 1/3, those are constants. And if you're classifying them by degree, they're still constants. You do not need to elaborate any further. Linear is an example of a first degree. That means you only have an x term. So 3x plus 5 is an example of a linear. And by only one x term, that didn't come out right. A linear polynomial means that its highest degree is just an x by itself. So there is nothing higher than x to the 1, and therefore it's referred to as a linear. Quadratic is a second degree polynomial. That means its highest degree is a squared term. For example, 4x squared. That's a quadratic polynomial. A cubic polynomial is a third degree. It means that its highest degree is a 3. So I could say x minus 2 plus x squared plus 5x cubed. There is a polynomial, 1, 2, 3, 4-term polynomial. Highest degree is a cube. It's a 3, and so we refer to it as a cubic polynomial because its highest degree is a 3. It's a third degree polynomial. Quartic is when its highest degree is a 4. So this is a fourth degree polynomial. Quartic, a good example of a quartic would be, go easy, x to the 4th. That is a quartic polynomial. Quintic is a 5th degree. I'm getting really close to the bottom. I gotta move up a little bit. There we go. Quintic is a 5th degree polynomial. An example of a 5th degree polynomial, we could say, well, if I didn't run out of space, I could say 6x to the 5th minus 4. Again, how many terms I put doesn't matter. What matters is that the 5, the degree of 5 is the highest degree that you'll see. So I could actually put x cubed here, and it would still be a 5th degree. Now, what could I add to this? 6x to the 5th minus 4x to the 3rd. That would make it not be a quintic or 5th degree polynomial. So if you understand what we just did, you could answer that question. What could you do to 6x to the 5th minus 4x cubed that would make it no longer a quintic or a fifth degree polynomial? There's a lot of things you could add to it. One thing you could do is you could just add a higher degree, x to the sixth. Now it becomes, you're thinking, oh gosh, what's a sixth degree? You only gave me up to a fifth degree. We call it a sixth degree polynomial. You don't have to learn the special name. I'm sure there's a special name for it. I don't know what it is. So you would then become a sixth degree, and you could not be a quintic if you had a power of a 6. So I'm going to take that off because I didn't want that to be part of my example. Okay, so I don't think I did another page. I think this was, oh, I did. Okay. Here's what I did here. Go back here. I didn't have full closure. So this is by degree. So let's go back for a second. You can classify the terms, classifying polynomials based on how many terms they have. You can classify them by their degree, first, second, third, fourth, or nth. You can classify those first, second, third degrees by their actual vocabulary name. You don't do both. You don't call something a first degree linear. You just say first degree or you say linear. You don't say both. I require you to use their proper name: constant, linear, quadratic, cubic, quartic, and quintic. Lastly, see if you can put this all together. Polynomial classification by degree and by term examples. So here we go. An example of a cubic monomial. I'm going to give you an example of a cubic monomial. I will ask you to give me examples as well. So a cubic monomial means that I can only have one term. Let's put this over here. Let's just use this whole space. I'm going to use this entire space here to put examples of each. So first we'll do this cubic monomial. So I can only have one term, and it has to be cubic, x cubed, and that could be it, x cubed. I could fancy it up a little bit. I could put a negative sign in front of it to make it even more fancy. Now there I still have a cubic monomial, negative 5x cubed. Let me give you, move on to the next one. Quadratic trinomial. Well, my box is too small. Hang on. I can't fit a quadratic trinomial in that space. All right. How many terms do I have? I have 3. All right. What kind is it? It's a quadratic. You want to look back? Quadratic is second degree, meaning its highest exponent is a 2. So, okay, x squared. Then the other 2 spots, you have to fill in the blank with something that's not an x squared, and you can't go higher than x squared because that'll make it something else. So do maybe 4x and maybe just a constant, 7. Then put signs in between them, doesn't matter what. And there is an example of a quadratic trinomial. Very popular quadratic trinomials in the world of Algebra 1. Let's do the next one, linear monomial. Okay, monomial means one term. Linear, I'll look back, example of linear, something to the first power, an x that's raised to the first power. So, x, I have to have an x, 2. 2x, that's an example of a linear monomial. It's one term, there's no pluses or minuses. Don't think this is 2 terms because there's 2 things. A term has to be separated by a plus or a minus sign, for example. That's 2 terms. I think people get confused with that. All right, that's an example of a linear monomial. Let me go to quartic binomial. All right, here we go, quartic binomial. I'm ready for you. Binomial meaning 2 terms. Quartic meaning your highest degree. Want to go back? 4th. Okay, so highest degree is 4. So I'm going to put that down, x to the 4th. Now, it doesn't matter what else I put, as long as I don't put something higher than a 4 as an exponent, or another x to the 4th. Well, no, I can't put anything higher than an x to the 4th. Yeah, no, that's right. And I don't want to put another x to the 4th here. Now, that's not going to be a quartic binomial. Do you know why? What if I did that? X to the 4th plus x to the 4th is 2x to the 4th. So see, you have to simplify. Because if you simplify x to the 4th plus x to the 4th, those are like terms. You can combine them. 2x to the 4th is actually a monomial. So that would be a quartic monomial, but we asked for a quartic binomial. And so we don't want to do that. Now, do we? No, we do not. We want to make that something that can't combine. Make it a cube. Put a 2 there. Put a negative there. Make it fun. Sauce it up a little bit. Make it look fun. Isn't that fun looking? I think it's fun. All right, the last one. Constant monomial. A constant monomial. Ooh, constant I'm picking a good color. Monomial meaning only one term. Constant meaning, you want to go back? Oh, a number by itself. 1/8. Bet you didn't see that coming. 1/8. That's a constant monomial. It's a number, no letter, and it's just 1. Now, don't think you could do 1/8 plus 3/8, right? And think that would be a binomial, right? No, that would be a monomial. That would still be a monomial because you would combine them. 1/8 and 3/8 or 4/8, which is a half, and that's a constant monomial. So you have to always make sure, and it's monomial, I wanted one term, but you have to always keep in mind that when you're doing this, that they can't be combined, because if you can combine them, a lot of times they're going to change. If you can combine them, they're going to change what you wanted them to be. Now, that's everything, and that's a lot. There is a practice on CUDA software. Go to CUDA. CUDA has practice classifying polynomials, and there's lots of practice in class. This is a memorize, guys. You have to memorize your names by degrees and by terms. You have to be able to classify them and also give me examples of types that I ask you to do. All right, so study, review, come back to class, ask questions, and see ya on the flip side.